Now the recording has been started, and I've also started the recording. Brilliant. All right, great. And today I'm going to make Sahib also panelist. Now we can all use the chat window to ask questions and answer. All right. Just that I'll have to make sure that I'll be repeating the questions. Brilliant. So there were these two topics which we had left, that once we cover the big data ecosystem, then we will go through the Flume. So far, we have gone through the entire big data stack except for these few tools. Now, last time we went through the pig stack. So pig basically makes it possible for you to write queries in in a very user friendly manner, so that you can churn humongous data and do the data cleaning for the further processing, or you can do a bit of data research as well. All right, great. Now moving ahead with. All right, so when we talk about big data, the one of the biggest tasks when we talk about big data is transport of the data, moving humongous data to your data center, because it takes a lot of time, and transfer of the data is very error prone. I did not realize the value of I did not realize the value of transport unless I visited one of the Yahoo's team. So, so when I was at InMobi, there was a Yahoo office next door to us, and there were some friends there, so I visited them. So, interestingly, they had a very huge team in the big data transport. Okay, so that team's responsibility was to transport of the data, and this team was not DevOps guys. These were good developers and researchers and architects. So that was interesting part, because when we deal with big data, one of the very important aspect is transport of the data. All right. And this transport is generally underestimated by the new players. Okay. So at InMobi, we also ended up having a huge team for the data transport. All right. And that is the reason why Flume and Scoop, these transport tools, these are the transport tools which transfer the data from one place to another. All right. So let's start with an interesting idea called Flume. It's a very interesting product. So when you have to transfer lots of data to a single place, you use Flume. Okay. When you have many machines or hundreds of places from where you have to gather data, then you use Flume. It's a distributed, reliable, and available system for efficiently collecting. Collecting is the keyword. Aggregating and moving large amount of data from many different sources to a centralized data source. Okay. Now let's see how does it work. All right. So as you can see in the diagram, there is a web server, and then this big rectangle, it is one of the Flume agent. So Flume, when we say Flume, it's always a network of Flume agents. There are many agents installed on many different machines, and all of those agents are doing is they are transporting data from various machines to a central location. So here the data is going from your web server. Now, what does web server mean to us? Let's say there is a web server which is generating lot of web logs, error logs, access log. Error log contains what are the errors occurring on your web server, and access log contains which all links are being accessed by the user. All right. So when people visit web server, the web server generates a lot of error messages, or as well as lot of debugging information, such as this user came from this IP address, and this user came from that IP address with this particular URL at this particular time. Okay, and the header of the OS was this, country was this. So there are a lot of information, time zone and other things, which are recorded on the web server. And when we talk about analytics of big data, most of the analytics of the big data actually starts with the web server logs, because that is probably one of the biggest data source data uh, user customer data for you. All right, and that is one data which you find difficult to manage, because if you try to store web logs into the database, the cost per MB is too high, because you have your database licenses, and even if you keep on distributing them, other than labor of dividing it into multiple database servers, it is also the license cost which is going to be high, and redundancy backup. So the trade, when people think about maintaining web server logs, the cost for the maintaining logs in the database is very high, and therefore people end up deleting most of those logs, and which is a very very bad situation. So if your organization is deleting the web server logs, they should immediately have at least HDFS installed on the cluster. Okay, and that's generally a starting point for most of the people. So there is this company, small company in India called Common Floor. So they recently moved to Hadoop. The single most reason was that they wanted their web logs to be cleaned and processed, and they were anyway finding it very difficult to manage the web server logs. Okay, so basically Flume, you install Flume on all web servers, and then Flume pulls the data from all the web servers to a central location. Okay, now a little bit more details about Flume. So Flume, when you start a Flume agent on a single machine, you configure it. You configure that, hey, this Flume agent is going to read from this particular service or this particular port, and then so that is the source, and then agent will also configure that, hey, I want to write to HDFS, okay, or I want to write to another agent. Okay, so when you think about an agent, so agent looks like this cable, USB cable. From one side there is a source of electricity, on other side is the sink. Okay, similarly source of data and sink of data, so that you can think of that way. So this cable or this Flume agent is always running on a machine and listening on a particular port. Okay, so Flume agent consumes data from the source side and pushes data onto the sink side. Now you must be wondering, what is the point of it? Why couldn't this service push the data by itself? The reason is, the service is, we cannot touch an existing service. If an existing service is writing to the file, it's writing to the file. You cannot change that behavior of that service. In order to pull the data from there, you'll have to write an external agent. And that's where the Flume comes into. You can tell Flume that, hey, keep on reading this file and keep on pushing it line by line to the HDFS. So that's the definition of source and sink. So keep on reading line by line from this file is the definition of sink. We call it tail minus f. We will are tailing a file, and um, then when we are saying that, okay, isn't once you have read, as soon as you read the data, put it in the channel, and then parallelly you push it through the sink. Okay. Now what's the point of this channel here? The objective of channel is to make the process of source and sink parallel. That is the beauty of this agent. So the agent does three things. It provides you the enormous amount of ability to read from various sources, whether you are trying to read from a particular port, or or you want to read from database, or you want to, even that database is okay, you will be surprised to know that. And this is on the sources part. You can also define that keep on tailing a file, as in chase a file, as in when user is some process is writing to that file, read the new data, and and and, and keep on reading that data. Now here you can see that from source it reads, and sync it puts so sync by default is generally people go for HDFS, but when you have a network of agent, the sync could be another Flume agent. All right. Now what is more important is here is a very interesting concept in distributed computing or parallel computing is the producer and consumer. So when this Flume agent is running, if I had to write this program by myself, all I'll do is first read from source, then write to sync. That's it. What's the point of channel? Correct? I would not have a channel. Now, what would happen is if this writing to sync is taking time, you are not reading from the source, and you might be missing a lot of data. So you will miss a lot of data if you are busy in writing to sync and you're not reading the data. Therefore, reading from source and writing to sync has to be done parallelly. And the most beautiful way of doing the parallelism is by creating a pipe between two things, so that the sync source will keep on reading the data from the source and keep on putting the data in this channel, and this sync will keep on. It's like making two people and having a assembly line. Okay, if you remember that conveyor belt, on one side one user is writing and other side other user is reading, or one user is putting the stuff on the conveyor belt, other user is picking the stuff from the conveyor belt. Now here the beautiful part is that imagine that there was no conveyor belt between the two people who are transporting some stuff from one place to another. What would happen is the first one would wait until the second one is free. Okay, so the whole work becomes sequential, and this is the basic premise of most of the parallel computing. So you always create these small pipes between two different processes so that they can individually function. Okay, and this was actually one of the things which I worked at Amazon as well, where I created a mechanism so that this channel piping and everything is automatically done. It automatically decided how big a channel should be. Okay. Now there is one more tiny bit in the channel and source and sync. What happens is that in these are called producer consumer, by the way, and it's a very big important phenomena in any computing or analytics world. So very important. I mean, lots of us do not pay much attention to this part. So what happens is when this channel becomes full, source stops to put the data, and when the channel is empty, syncs stops to read the data. It will wait till there is a data, and that's what causes the synchronization. Okay, instead of creating threads, creating this block, creating that lock, the queue or the channel solves the problem. Okay, so of this is an important aspect of having a channel and source and things. All right, now as you can see here, the wire represents the channel and source and things. So that's the way I have tried to explain. Now sometimes you have many web servers and you want to connect them to something and then send it further. So you can actually make a full network of Flume agents. Keep in mind that Flume agent can already transfer data from one side to another, right? Now you must be wondering that how will we, deploy such kind of system? Will we go to every machine and create one configuration file for each machine and this and that? So the cleverness is that you can define all the agents configuration in one file, and then use the same file everywhere. Just that while launching the Flume agent, you can tell that I'm this is the name of my agent and pick only that configuration for that agent. All right, so that's how it happens. So Flume supports large variety of sources, and this we have already discussed. So this is how a Flume properties looks like. You can define, you have to put the name of agent, you define what does each sources do, each sync do, and all that. And then you can define channel. Channel could be totally in memory, or you can put it on the disk as well. All right, so this is how you can configure a channel. If you get a time, you can try it out, but that's not needed for this particular course. Okay, so that was the Flume. Basically, using Flume you can set up network of these agents which can keep flowing the data in the direction where you want. All right, all right, so that is Flume. Now, so although we call Flume as flowing of unstructured data, but there's a big difference. Flume is having its own agents. Flume is not, like a command line utility alone, right? But okay, it is basically a proper service which listens to a port and writes to some other destination. Okay. Now next is Scoop. What is Scoop? It's an open source tool. It extracts data from structured data sources into Hadoop for further processing. Okay. Now, uh, generally, most of your data, most of your relational data would be there in MySQL, Postgres, and so on. Now, let's say you want to move all of that data into Hadoop. Let's say you want to move all of that data into Hadoop, that's when you will use Scoop. Okay, Scoop comes up with Scoop has all JDBC driver compatibility and is very straightforward to use. If Java can connect to it, Scoop can also connect to it. All right, so it's as simple as that. Okay, so your question would be that what is so big deal about transferring the data from a database to Hadoop, right? You would say that why don't we just create why don't we just create a small Java program and then read from database and start writing this side? Okay, yes, that's exactly what Scoop is doing, but Scoop has taken a step further. The Scoop has made the whole process distributed. Meaning it will run Scoop will run map reduces. Okay, there will be no reduce, although it will be only maps, meaning each map will be reading data from database and pushing it to the Hadoop. Okay, now that also means will there be many connections to your database? Because when we are saying that Scoop is distributed, and every time you launch Scoop, it will go and schedule a MapReduce process where each map will be talking to your database. So yes, there will be many connections from your network, from your Hadoop cluster to your MySQL or Postgres or Microsoft SQL. So that is what is known as Scoop. All right. Now, so you can do every kind of thing. I mean, you can move data from a structured data source, maybe MySQL, Postgres, Microsoft SQL, or anybody which has JDBC driver. In case you have a database which does not have a JDBC driver, it provides a way to do the extension framework. People can write the connectors. So to see all of the commands you can write, you can see Scoop. Okay, if you go to command, you can click on Scoop and see the various options available to us. All right, now, okay, so The available connectors for almost all databases are there, and in case there is no connector available, you can use the generic JDBC connector if you have a JDBC driver for it. And uh, I mean, for sure, there won't be much of a connectivity problem for Scoop. Okay, and all you have to do is, all right. So if you want to have a demo of some of any of the component, you can tell me. I can give you the demo. All right. All right. So using Scoop, you could transfer one database table from, say, MySQL, Postgres, Microsoft SQL, or Oracle. You can transfer a table from there in as a file into HDFS. Okay, as a file into HDFS, or you can transfer a what do you call table from any of these structured sources into a Hive table. We will talk about Hive. Hive also has tables, and Hive is basically Hadoop based, HDFS based. Okay, and you can take the table from these any of these sources and put it into HBase. Hope you remember our discussions on HBase. Okay, so you can do all of that magic using Scoop, and you can do the reverse as well. You can take a table from HBase or Hive and put it back into MySQL or Microsoft SQL. So that is the role of Scoop. Okay, so when I say or export, import or export is always with respect to, the way to remember is that you are standing inside Hadoop, which means import means you're pulling data from structured sources into HDFS. Export means you want to push the data, take the data from HDFS Hive or HBase to the external database. All right. All right. So So first of all, you can create a dummy database in your MySQL. Here, what I've shown is go to the folder where MySQL is installed, then run MySQL underscore safe, that is the database. If the database is not running, then you connect to the database and create one, the what do you call schema. This is a database in MySQL, and some people call it schema also. Now, this is very important aspect, the one that every one of us forget, and I've seen the developers giving me this excuse. So it works on my machine, so everybody tests on their virtual machine and it's working fine, and the moment it goes to the cluster, it doesn't work fine. Why? Because the database has to be made accessible to the cluster. Okay, why? Because the whole cluster might be contacting your database, your whole the Hadoop cluster, various maps which will be running parallelly when you say import or export. When you say export, or let's say you say import the data from database to HDFS into as a file. Okay, comma separated file. Now what would happen is, as you execute this job saying scoop import the data, okay, from this database, this is the URL, this is the password, and import the data. What will Scoop do is it will create a MapReduce process, and that MapReduce process will be executed on Hadoop cluster, and every map will be making a call to your database to get the data. Now this map could execute on a.cloudxlab, b.cloudxlab, or any of the hosts in the network, right? There's no guarantee that will be executed on a particular mode. Okay, because here, since there is no input file, the number of nodes which will be selected for running maps will be based on which nodes are free in the cluster. So maps will be running on the whole cluster to import the data. All of these maps, the logic inside every map would be connect to the database at this port and read the table from there, these many rows, from first 20 rows, or from this row number to that row number, read those row numbers, and and push the data to the uh, HDFS file. Okay, that also means that there will be many files created parallelly based on number of maps. All right, so you have to make sure that your cluster is all every computer of the cluster the contact the database server. All right, although but it's pretty obvious, but we make a mistake. I made a mistake in the beginning, and almost every student makes that mistake. So here we are creating dummy data into MySQL, saying create table widgets. These are the columns, these are the fields, and then we inserted some dummy data there. Okay, then we said scoop import. After connecting to this database, import the data from this JDBC driver. Although here uh, it would be c.nobigdata.com/scoop-ex3. Okay, because now the name of the domain is c.cloudxlab.com. Okay, now here this particular table will be pulled. This particular table will be pulled from this database. Okay, and these are the login password for this database, and then a number of mappers which will be used to pull this data is one in by default. Had it been two, there will be two files in this folder at the end of it. So once you execute this command, it will create a folder called widgets, and that widgets will contain the parts or contain the comma separated data from that table. All right. Next is that if you just want to create, all right. So this is how we pull the data from the relational database into HDFS. Okay. This is how you pull the data from relational database to HDFS. Here we are talking to MySQL and pushing the data to HDFS. All right. Next is when we want to do it in Hive. Okay, Hive is sort of a database. Okay, we will talk about Hive, or you can think of Hive as similar to Pig. All right, so the way we do is either in the two steps, saying first create a Hive table and then load the data in that table. Okay, or we can tell Scoop to do everything in a single step. That's what it's doing here. All right. Next is that you might want to push the data from relational database to HBase. Now, what exactly is the problem? Problem is in HBase you have column families mandatory, right? You have a column family mandatory, which means that while saying that bring the table to HBase, you have to tell that what kind of column family you will be creating there. Also, the other mandatory aspect of HBase is, as compared to our relational databases, other mandatory part is that we have to have an ID column. Okay, so when you're importing a table from relational database, so the question from Scoop to you would be, hey, good that you have told me the name of the SQL database, but while creating an HBase table, what should be the name of column family? And these records, what will be the row ID? Correct? And that's what you have to mention in the command. You have to tell, hey, this is my MySQL URL. This is the table which I'm talking to, and bring that data from there to an HBase table called customer into a column family called CF1. So if this customer does not exist, it will create. If this column family does not exist, it will create this column family. And then for this username and for this password, this is the username password for the MySQL. And then we'll say that create the HBase table as well if it doesn't exist. Now, sometimes what we want to do is we want to say We have multiple column families. Okay, in a table, some columns go to one column family, some other columns go to some other column family, right? That's if that is the thing you want to do. Okay, so what you do is you create the table, and at a time you will be only moving data to only one column family. Okay, if there are multiple column families, then you will execute this command multiple times. Okay, some columns are going to one column family, some columns are going to some other column family. The selection is going to be based on the row key. Okay, so if your row, there is an identifier in your table, then it'll be very easy to do the hbase import if there's a unique identifier for every row. Otherwise you have to first figure out what should be the identifier for every row. Okay, Mehdi and Anusha and Sahib, did I make sense so far? All right, great. I think Sahib is not around. All right. Now we can do this reverse of it. Okay. Once you have some Hive tables, you can move the data to MySQL as well. In the same way, just that this time you will have to say Hive to MySQL, as in you have to say export. All right. That's it. That's pretty much with respect to Hive. Any questions on Scoop and Flume? So we have just talked about two components. Okay. One is to bring the data in parallel continuously. So, so Flume is a continuous thing. It keeps on going day and night, while Scoop is on demand. So Scoop will transfer the data whenever you want it to transfer the data or you want to schedule it. Okay. All right. So that's about transport of the data. Any questions? All right. So Anusha is saying that can you show us practically Scoop and Flume? Yes, I can do that. All right. Let me try to show you practically. All right. Let's go back to what we were doing here. All right. So this is the Flume agent. Let me go to the folder where is my terminal? Okay. So I will open a console. All right. As well as I'll open Hue. Let me open Hue as well. Okay. And let me open a console. All right. Increase a bit of font, login, and password. All right. This is the. All right. I don't think we have. Yeah, we have a scoop transfer here from the UI. Anyway, so first we will try to do one thing called OZ. So that a sample configuration is available in Hadoop fs-ls and slash data. So you can see here there is something called Flume here. So the sample configuration is available from there. You can download it. I've already downloaded it locally. I've said Hadoop fs minus copy to local and downloaded conf folder. You see the conf folder here. This contains the Flume properties. Okay, this contains the description of Flume. It says that I am going to read the data from this particular port. Okay, this is the source. Source is going to read the data at this particular port. Whosoever writes to this particular port will be able to send the data to Flume. Okay, and Flume will continuously push the data to this particular folder. All right, let me delete this folder for myself so that you know clearly that I'm not cheating. All right, so Hadoop fs minus rm minus r. So I'm deleting that folder from the HDFS, and then I'm going to run the command which does this Flume agent. And what does it do? Let's try to understand. What does this command do? It says Flume ng, which is next generation of Flume agent. I want to run the agent. This is the config file defining source and destination and channel, and this is the folder containing the config file. All right, so that's so this is a config file and that is the config folder. So we can run that. And see, as I was telling you, this simple single file might contain the configuration for many agents. Therefore, you have to give the name of the agent for which you want to pick up the configuration from. Okay. If you have, say, 50 servers running, you would like to basically have all the configuration in a single file, copy it everywhere, and then automate it rather than having 50 different files. All right, so let me get out of conf folder and say this. Now, what we'll see is it has started listening to this particular port. Okay, it has started listening to a particular port. Okay, now let's open one more console. Okay, let's open one more console. You can see that. All right, let's open one more console. All right, and then connect to the local host on which it's running at this particular port. Sorry, is it running at, oh, is 1 more 4. All right, now you will notice that if you go into Hue and go into file browser, okay, the folder which we configured as part of sync configuration, it will create that folder, and that folder was Flume data, right? Okay, so there must be a folder called Flume data. Did it create? No. All right. All right, let's put more data into this. Okay, so I'm starting putting the data, a lot of it. So it says that it's writing to this particular place. Okay, now you can see here, if you go here and sort it by, you can see that it has created this file. All right, so it is putting the data in a binary format. It's a bytes writable format. We can change that from configuration. So as and when we are writing to it, we'll be creating more and more files into this folder. And inside your Apache stream, inside the Apache streaming, we can process this incoming data by saying that read, we can tell Spark Streaming to keep reading the data from this folder. And as and when more and more file will be created, automatically the windows in Spark Streaming will be created on each small file, and then it can be processed. And that is the reason why Flume keeps on creating data in a small size but many files. Okay, So you can see we are not here, sorry, not this. This is where people keep on writing and it'll keep on getting pushed to the HDFs. I'm I'm typing really fast and putting it there. And the data is continuously going to this place. Okay. At this point, instead of we refreshing it, there could have been, we could have started our Python, PySpark or our Spark streaming and would be consuming this folder, which will be consuming this folder. Okay. You can see that lots of files are being created. All right. Make sense to you, Mehdi and Anusha? So we are using a command called nc, which lets us communicate to any program running on any port, whether it's an email server, whether it's a web server, any server you can talk to using commands like telnet or commands like nc. All right, good, good. So any questions at this? So this, there are two terminals. One is here, other is here. This terminal is running our agent. And what is this agent doing? It's listening on a port, and whatever you write to it, it's writing to the HDFS. And here we are writing directly to this. Also, if you are also logged in at console, then you can also start writing because there is no permission restriction on this. Okay, this is available to all the users. Okay, and how am I connected? I'm saying nc this port, this host name and this port. Okay, so that was about that. And this IP address is basically the loopback address. It's not a universal address. Every machine has its own name. It's like saying myself. All right, local host or myself. Every host has local host and and this IP address. Good. So this is how you can communicate to Flume, and you can get the data. Now let's move ahead. Let's try to do one sample import for maybe HBase. Should we do for HBase? All right. Let's imagine that there is a database table. Okay. There is a database table, and first let's check where is the database table in, say, what do you call? I think it's cloudxlab.com. I think it's a C or D. I'm not sure. I think it's C. I'll have to check. So let me, I'm in the console. Let me go to the console. Here I say nc c.cloudxlab.com 3306. That's the port at which MySQL runs. So you can see that it's running fine. It's running on C. Okay. Now I could say, all right, all right. All right. So I'll have to take the latest settings. I'll have to find out the latest settings, and I don't have it right now. Let me do one thing. Let me. Okay, just give me a second. I need to find out the password for MySQL, and I don't have it. Alright, so I'll pause my screen for a second. All right. So I'm back here and okay. All right. So okay, so the thing is that we have to connect to MySQL at this with this user and this port. Okay, this host name and the password is this. Okay, so let's try to in one of the terminals we will say this is the MySQL one, and we will have to paste our password. All right, now you can see that. So we'll say show databases. So there is only two databases. We say scoop ex and we say show tables. There's only two tables. One is sales and other is widget. Okay. So here select star from widgets. You can see that this table exists here. Now let's take this table and push it to the HDFS. All right, let's do that in another terminal. All right, so we can do the same thing from the UI as well. All right, so what do we do here? This is the terminal. So this table is already created and database is already created, the sample one. So we don't have to go around this. Okay, so let's try to modify this command. Okay, and here the host name has to be changed to this one. And what was the database name again? Database name is scoop ex. Okay, so we'll have to say scoop ex here instead of scoop here, and the table name is this, which is correct. Username is different. Username is username was when we connected here, scoop user, and password was this. All right. So we are saying import from that place a table called widgets. But before that, let's see if it already exists in our HDFS. So I'm saying Hadoop fs minus ls to check if it already exists. So no, it doesn't. All right. So we can execute this command, and we can, all right, we can run it. So it's connecting to MySQL and bringing the data from there to our HDFS. Okay. So if I go to my home folder, now here a widgets folder will be created, and the data will be there in that folder. I'll have to sort it by time. You can see the same data has come here. And also you can see that this part file is generally created when the result is generated by MapReduce. Also, one more thing to know is that when part-m is there in the output file, it generally means that the mapper has directly written to the HDFS and there is no reducer. All right, so it has successfully, and here also you can see when it executed the job of importing data from MySQL to here, it executed MapReduce. All right, you can see all of the same format when we run our Hadoop MapReduce or any other MapReduce job. The same thing has happened here. All right, so so that was how you can run the scoop command. All right. Similarly, you can execute the other commands mentioned in this demo. All right. You should try it. Okay, Mehndi, Anusha, and Sahib, you should try it, and it should not be very difficult. All right. So that's pretty much with respect to Scoop and Hive. All right. Is that good enough, Anusha and Mehndi? Do you want me to go through all of the demos, or you want to try it by yourself? I might be going little faster now and then. You can stop me and make me go a little slow. Okay? You can tell me that okay, I'm going a little fast. Can I slow down? All right? It's okay to go slow. All right? So okay. All right, Mehndi. So Mehndi will try later, and Anushai, yes. Okay. So please try later. And one more thing, that was our Hive demo. Now let's move on with the other discussion. So today's discussion, which we had planned, was actually Hive. All right. So we have been able to successfully run Scoop, and we have been able to successfully run Hive. All right. Not here. Okay. This is the one I want. Good. All right. Let's take a break for quick break for 5 minutes. All right. Let me save it into class notes. I think today will be 11 class or 12th class, 13th class. All right. So, okay. So this, let's take a break for 5 minutes. Back by 9. All right, I'm back, so we can start now. All right, Mehndi is back, and Anusha, should we start? And Sahib. All right, all right, let's start then. Great. All right, so today I'm going to discuss another very important concept and another very important product with respect to the analytics called Hive. Okay, that's what I'm going to discuss today. Now, all right, great. So again, since there are a lot of people who already know, almost every IT engineer knows databases. Almost uh, more than 50% would be knowing the SQL very well. So anybody, whether he's a developer, whether he's a sysadmin or DBA or BI or manager in IT industry, everybody ends up learning SQL. Okay, because everybody depends on data and everybody depends on the infrastructure. Okay, so So there, so basically there was a huge need of getting things done using SQL rather than coding or rather than rather than using Pig, because Pig is great, but again there are lots of people who have already written lots of SQL and stored procedures in many languages. Okay, okay, so the value proposition of Hive is that it's mostly suited for data warehouses. It's relatively static data that needs to be analyzed. Then Hive is great. And when we don't need fast response, because at the end of day, every query that is written in Hive is basically going to execute Hadoop. Okay, going to execute Hadoop MapReduce. Therefore, every query has the in latency, a decent amount of latency. Therefore, if you don't require fast response and you are churning relatively static data, then Hive is great. Okay, it's good for moving part or most of your data warehouses data and churn the data inside Hive. It makes it easier to port existing products. Okay, provides SQL dialect called HiveQL, which is very similar to standard SQL. Also, if you noticed in Pig, when we say that A equals to load some data and then we churn this, churn that, but when we exit Pig, those dataset no longer exist because they were just in memory. Okay, but in case of Hive, whenever we are loading data, we are always creating a table. Okay, we are creating a table, a persistent table. Now, now to have this table, we require some storage. Where does it create this table? So Hive create this table in something called metastore, and this metastore is generally stored in MySQL. All right. So and it allows querying HDFS files and HBase. So Hive, using Hive, if you have, let's say you have a very big file which is comma separated, you can basically create a Hive table around it and then start querying it. Okay, although it's a file stored in the file system, still you can create you can start working on that. Okay, so Hive is basically your way to churn data, your way to churn data by the way of SQL. Okay, so you give your SQL, it converts internally into MapReduce and get your work done. Okay, Hive is not really database. It is basically sort of read only. Okay, although there are newer formats in Hive which lets you insert data, update data, but those are not yet proven, and those are not, they're just for very small section of the work. Okay, if you store a Hive file as ORC file, there is another format called ORC file, then you can store data in Hive table, update data, delete data. But in general, Hive was not designed to delete, update, or insert data. Hive was just for select queries. Okay, at most you could do load. All right. So the limitation is it does not provide you the record level update, insert, delete, but it can generate new columns, new tables, not columns. So it's not suitable for online transaction processing. Okay. In transaction processing, you require really fast, but here the queries have higher latency because it's running Hadoop MapReduce, and which is batch oriented. Okay, there's a startup overhead of MapReduce. Okay, therefore Hive queries are not great for online transaction processes. When you it's best when you have large data sets that has to be maintained and mined. So Mehdi's question is, does it store data? So it basically stores data in HDFS. So if you say load this file into this table, it's going to take that file and put it in the HDFS. All right. So this is the standard architecture. So the driver does the main work. So you as the user, say command line interface, you are talking to driver and driver is converting your query into Hadoop MapReduce and executing on Hadoop. That's what it is doing. And then there is Hue, Cubole, and others who are talking to Hive. All right. The word count example here you have is okay. So So basically, if you have to run the word count example, this would be simple. But let's just go ahead and first have a hello world. All right. So there are many ways to execute Hive. One is you can go to Hue. Okay, you could go to Hue like here, and then say Hive here. Okay. Now you can see on the left hand side there is a database, and this is where you write your queries. Okay, so this was my query, the whole history which I had been doing. Okay, and and this makes us execute the and these are the tables. You can see these are the tables which are created by me, and you can go to the other databases. All right, so this is where either you can do from here, or you could go to command prompt and type hive. Okay, if you have your is SQL in a file, you can execute the whole file in a single shot saying hive minus f and the file name. All right. So this is the hive prompt. Just like pig prompt, you have hive prompt. This is MySQL prompt. This is Hive prompt. All right. As well, you can execute your query from here. So let's create your database. Whatever your database you want to create, please create your database. Don't because you won't be able to write into other people's database. Okay. So you could say create database, say BDASG. That is the name of the database, and say okay and execute. All right, so it's executing that. Now if I go back to my Hive and say show databases, it should be created here. Show databases, you can see that here it shows you BDASG. We can say use this particular database, or you could refresh it and then see the database. Okay, here you can see BDASG. There is no table right now. So this is the console. This is the Hue editor. All right. So you could also draw charts on a table from the UI itself. Good. Sounds good to you, Mehdi. Now moving ahead. So that's you can create a simple table this way, and then let's just say create a simple table here and say show tables. So we have created a table called X. We can start selecting from X. There is no record found. That's it. All right. We will talk about more after this slide. All right. So that was how you create you interact with Hive. So you can run all the Hadoop FS command, HDFS commands, and you can load the external script, and you can put the commands here, as well as you can set the environment variable using these variables and execute the shell commands with exclamation. Okay. Now there are many data types. The most important part to remember is that you will see a lot of data types. You will see for a single thing there will be many data types. There is a reason for it. The reason is that because lots of people must have coded many kind of queries, and those queries need to be executed on the Hive, right? Those queries need to be executed on Hive, and therefore there should not be any need to rewrite the queries. And hence, there are many data types. Okay, so you can data types for the same thing. For tiny int, boolean, binary, bit, so all of them are actually the same thing. Small int, big int. And if you see the data types for various columns has been kind of a universal superset of all the databases here. So you have string, varchar, and char. All right. So because Hive has to have all the data types with the other databases it has like Postgres, MySQL, and MS SQL, and therefore you will see lot of data types. Okay. And in every version they add more data types. And interestingly, that's something which you may not have seen in other databases. It provides you the complex data type. Okay, so if your data is in JSON format or is in XML format, you could create the substructures in which you can load the data. The complex data types are arrays, maps, and structs, as in it's a collection of key value pairs, and unions. Unions is an interesting part where you could have multiple data types in a single memory state. Okay, for example, in this table, the last column is union, which is authorization. An employee or a user could have authenticated with the system using either Facebook ID, Google ID, or email ID. Now, a user will only authenticate with your system with only one of these IDs at a time. Therefore, it is keeping only one information here. It's a single variable representing all three. All right, that is union. Union comes from the C and Postgres. All right, so databases are basically a way to manage the data, and you can use show databases, create databases, and etc. to create your segregation. So before starting to work, create your own database and work on that. So you can see show tables and see the list of tables. Select start from table will give you the return results from all the records from a table. Describe my table will give you describe my table will give you the details about the table, but I would generally prefer saying describe formatted my table. It gives me lots of details about a table. Okay, there are generally two kinds of table, managed and external. Managed are those which when deleted do not delete data. Uh, sorry, which when deleted delete data, while external are those which when deleted do not delete data. They leave the data as such. The data of Hive by default is in HDFS. Okay, anything you write into anything you copy to this table or insert into this table is going to basically create a file in the HDFS and put it there. Okay, so whether managed or external, external can be on any other systems as well, while managed will be inside the Hive itself. Okay, the metastore is in MySQL. Okay, the metastore includes what all databases are here, which tables are here, and the definition of the table, like name of the table, columns, and partitions. Okay, that is Hive. So basically, when since data is in HDFS, so data of a Hive table is in HDFS, and therefore therefore the data of Hive is in HDFS, and Hive needs to store the table definition so that when you log in again, the table should be there. It should not disappear. Therefore, to persist the information about the view or view, it has to keep it somewhere, and that somewhere is Metastore, and it is in MySQL. Okay, so that is Hive Metastore. Next is you can start creating a managed table like n by SE. Let's try to do our first table. Okay, let's try to do our first table. Okay, so let's not put the location. All right, it says create table n by SE with these details. All right, and our database is this one. Let's see what errors we get. Okay, no errors, which means it has been successfully created. Good. Now next is, where is the next one? So now next is that let's load some data into this. Okay, we can load from HDFS using this command. Okay, using this command, and it will copy the data into the file. Okay, there are other ways as well. There are UI ways also, but I want to show you the right way, the command way. You can also say go here and import table. Okay, all right, all right. So let me just open one more window. So here in the data folder, what do we have? we have these, that's okay. And all right, so let me just go up to slash data, and here you have NYSE daily, NYSE daily, NYSE dividend. These are the file. Let's just copy these to our folder. Okay, let's just copy it to our folder here, and inside say Hive. Okay, so I think it is created now. Yeah, it has created a folder called Hive, and in this there are these files. All right, let's try to load this data and into our. So I've copied the data to my home folder, and my home folder is Hive, inside which there is a file called uh, NYSE daily. You can see that Hive NYSE daily. All right, it's only 3 MB. Now I'm saying that this table name is this. So I'm saying load data in path this, override this table. And when you select something, what did it say? In path this, it says that invalid path. Okay, okay. I think I need what I need to do is I need to put the full absolute path here. Okay, let me just try to keep the absolute path. And all right, let's see what happens. Okay, so it has imported the data. All right, so it's showing us the data sample. You can quickly see that it has loaded the data, okay, into this table. This is this file here. All right, so this is how. Now this is no longer there. That is something you must note, and that is the reason why we tried to load it. Okay, so it basically it why we try to copy it, because every time you load a data from HDFS, it does move. It moves the data. Okay, all right. So you can copy the data from either local directory. This is only for valid for if you are running the console. Okay, this is not valid for the Hue. Okay, so you will be loading the data from HDFS. So we have just now loaded our data from so this is where is this? So this similar to this one is our file which was here, and we loaded it into Hive. Now we can start doing all kinds of things, all kinds of queries on this table. We could say select star from, say, select name symbol and average of, say, price open. Okay, price open. And what is that price open? I'll say price open from NYSE group by symbol symbol 1. Symbol 1 is the name of the column. Now what you see here is an interesting thing. So we are actually churning our data stored in HDFS, which means this data could have been in terabytes, and still it'll give you it'll give you the results. Okay, using MapReduce, using the whole cluster. All right. So that is the beauty of Hive, that all the complications of MapReduce has been hidden away from you. You are acting as if you don't know about whole Hadoop cluster. You're simply concerned about data. So that's what is the role of Hive in the whole big data stack. All right. So you can see that we were successfully able to do this, and we can also do very complex queries. This was just a very simple query. All right. So by default, the data is located in this folder. You could go there and check. Okay. You could go to that folder and say here and check. You can see this. We just created this folder. As in when we create the database, it creates the folder. And when we said load the data, it picked my home folders file and brought it here. All right. Does it sound sensible to you? Okay. So we were able to load the data. Now you can start churning. There's not much of a science around it. Okay. Now there's an idea of partitions, which means if your data is stored in multiple partitions, you can load that data as a table, and the criteria behind which the partitions were created, you can have one more column in the table. For example, let's have a look at it here. Let's say you have this file containing Sandeep and Shravani, and there are two rows. Now you create a table called employees, okay, and which has these four columns and which is partitioned by something and row formatted by something. Now, when you say describe formatted, you will see the detail about this table. Now, what you need to notice is this contains three fields. These are the main three fields, and there is one extra field called qualification. So every time you uh, and if you have multiple such files like the amp and the amp1, you can insert into employees table. Okay, this all the records from this file, and you will have to explicitly specify this table, this file belongs to all those records where qualification is 1. So it will create one more column called qualification and put 1111 in that column. Okay. And similarly, it will create another column called damp1 for qualification equals to 2 and put the data there. Okay. All right. So you could also see that Hadoop fs-ls would give you this. Okay. And also please notice that every data you are copying to Hive table is basically taking it from you and putting it in this HDFS folder. All right. So that's pretty much about partitions. You can have all kinds of data definition language like alter table, and change the column data types, drop a partition, create a partition. Also, there is one another kind of tables called external tables for which the data will not be in apps warehouse. It will not be created there. Basically, the objective of external table is the data that you don't own is external table. Okay, data that you don't own is inside external tables. Alright, so you can basically churn the data lying at S3 and without having to copy the whole data. Instead, you can specify that in the in the Hive configuration, or while creating a table, you can say that this is an external table. All right. And you can also have tables where you have, when you say this is my external table and my data is lying somewhere external. So maybe there could be multiple such locations where your data is lying remotely. In those cases, you can have various partitions, and for every partition, you can say these are the additional column values. Okay, so that is the purpose of the partitions. All right. Each table has got a location. By default, that table is a directory under the location this. By default, there is a folder with the name same as that table. You can override that location by explicitly mentioning location. If there is already data in location, then that data is not deleted. You can continue and start using that same data. Okay, so in Hive, the table is nothing but kind of a window on the HDFS data. In very simple words, you can do the select statements on the query, complex ones. You can do a complex projections. For example, here, this is an struct. This is a structure which we are, sorry, this is a map from which we are reading this particular key, and we could have we can call functions, and we can do arithmetic operations. All right. And as well, we can do the aggregations, the standard count, average, sum aggregation function. And sometimes we want to do some aggregation functions on the mapper side itself. In those cases, you could say hive.map aggregation is true. Also, when your query gets complex, you can create views. So when we say create this particular view as this, so it's not bringing data from here and putting it here. No, it is just creating a view over this. Meaning, when you run select star from tweets underscore clean, it's going to execute this query. Okay, that is the objective of a view. All right, that is the objective of a view. All right, next is creating custom class. Okay, you can create custom class, but I think that'll be too much out of scope for it. Sometimes you want to load data from JSON. In those cases, you can download the JSON binaries from here. That's a source. And JSON SADA is JSON serializer, deserializer. There could be many serializers, many ways in which a file data could be interpreted by Hive. So if your data is in the format of JSON, you could use JSON SADA. Okay, all you have to do is in the beginning you'll have to say add jar and the name of the JSON SADA. Okay, so this is the version number. Okay, this is the version number. Okay, and it's being basically this file contains the logic how to convert raw data into a row or into a table. That's what this JSON SADA do. So all you have to do is download this JSON, this particular binary, and then add it, run a query called add jar this, and then start creating your table like this. Okay, then you can start creating your table like this. All right. And while creating a next table, you can say that my row format is this. Okay, and the location is this. All right, so that's how you load JSON format data. Your data might be in XML. That too you can load. There are XML serializer, deserializers. Right. Sorting and distributing. By default, the problem with order by statement is that it'll route all of the data through a single reducer, meaning there'll be a single machine which will be doing all the order by work, which is not correct. Although it does guarantee ordering, but it basically pushes a lot of boundaries. I mean, it basically overloads one single machine. Therefore, always use cluster by X. So you have to use cluster by X. Okay. Either whenever you are sorting data in Hive, either you say select column 1, column 2 from table 1, distribute by a particular column and sort by the same column, or you could simply say select column 1, column 2 from a table and then cluster by column 1. Okay, so either of these syntax will give you the best sorting. Okay, and there is another idea called bucketing. Okay, bucketing is like creating index. It is to make your system little faster. So if you say cluster by user ID, a cluster by a particular column into 32 buckets, it will basically distribute the work, split the table into 32 buckets. All right, on this particular column value. Let's go and have one more demo. Okay, so let's say you downloaded this data called movie lens data. Okay, let's say we downloaded this data. One way of downloading this data is we go to this URL and then download the file, then upload it in HDFS, or we could go to the console. We could go to the console, and here we could say things like this. We could say wget. Wget brings the data really fast. So it directly, my server called e.cloudxlab contacted that website and downloaded everything here. So we could say things like unzip ml this. Okay. Now I could say Hadoop fs move from local and all right. Now you can see here this one. Okay. So this is where we have uploaded our data. Okay, here this is what is this? This is basically the movie lens data, the data about who has rated which movie how much. Okay, so you can see here u.data means, okay, it shows that this user has rated this movie this much. Okay, so now we can create we can create table around u.data. Okay, we can create a table around u.data. We could say create u.data. Okay, and let me just try to execute this. Okay, so and then we could say we will remove local because we are going to load it from the server itself, HDFS itself. And where is it located? Let's see. It is located at this location. So we will say from here till here. Okay. So we are saying overwrite into, what was the file name? File name is table u, this one. Okay. So let's go here into table, this one. So I'm saying load this data into this. Okay, and what is this? This is basically a table where the fields are which knows that the data will be terminated by tab, and this file which we have just loaded is terminated by tabs. So let's load this data into our query, into our table. All right. So let's say we have this. We select that particular row and execute. Now it has loaded it. All right. So that's the data about the users. Now I can start querying this data. I can start querying this data. Sounds good to you? Sounds good to you? All right. There's one more thing I wanted to demo to all of you is, okay, the purpose is to basically give you an overview of how is the analytics done in the big data world. So let's say this is one of the tables which you have created. Now there'll be lots of kinds of analytics you would like to do. Okay, there's a lot of kind of analytics you would like to do here. All right, now let's try to present this data as maybe a chart. Okay, you can see that it has quickly beautifully plotted the chart in a histogram manner. Okay, in a histogram manner it has prepared the chart. So you can also define the x-axis and y-axis, and which is looking really crazy. Okay, and y-axis is say rating. All right, so that's the chart which comes with Hue, but we can do a more of analysis using other ways. Okay, what do I want to do? Yeah, we could actually write another query where the results are there, and then we can straight away plot the data here. Okay, so that's a quick way of presenting data. Now let's say, where was my query? All right, so so if we have to do, if we have to find out for each movie how many users have voted for it, we can start doing that now. Okay, let's say what we are looking for is, um, let's say we are looking for the average movie rating. Select star from u underscore data, and we are looking for an average movie rating. Okay, we are saying movie id comma average of rating. Okay, from u underscore data. So it says that movie id is not grouped by, right? We have to say group by movie id. All right. So what you can see is that without writing any MapReduce, you have been able to churn a lot of big data. Okay. 90% of the time, your role will be to basically figure out how could you convert the whole problem statement into SQL queries and get the work done. So you can see that it has created this for us. It shows that movie ID 1 got this much rating. Okay. All right. Now, at this point of time, you could even join this table with some other and do the work. You could join this with something else and do the work. Or you could create a view representing this table, create, let's say, V1, okay, as this. Okay. You could create a view like this. All right. So every time you have select star from V1, you will have the results. All right. So that's the magic of, you can see that every time we'll say select star from V1, it'll execute the query. That is the role of a view. All right. Now I wanted to do one more thing. I wanted to tell you that have you any of you done any reporting earlier? Business intelligence reporting? Anusha and Mehdi, have you done any reporting earlier? All right. All right. So if you have not, if you have done any reporting earlier, you would be knowing about tools like BERT. Okay. Okay. So these reporting tools are very mature tools. They give you enormous amount of control over the data presentation. And that's where the beauty lies, and that's a very big advantage of running SQL. So so if you want to try it out, that's probably one thing you must try it out. Okay, that's probably one thing you all must try it out. You should download BERT. BERT is a business intelligence reporting. The UI has been designed using Eclipse graphical interface, and it's just wonderful. So I've already downloaded it. Okay, I've already downloaded it. Now, once you have downloaded Eclipse, it'll look like this. Okay, it will look like I downloaded in my download folder and extracted it to a folder called BERT. There was Eclipse inside it. So I start the Eclipse. Okay, it'll ask me for, say, a workspace. I just give some random workspace. Okay, now here is the magic, as in it's giving us a beautiful interface for manipulating the reports. Okay, next is that you can create your project and go to business intelligence, select reporting project. Okay, give the name of the project to something. Let's say I'm giving BDA demo. Okay, BDA demo. Okay, it says that it's a reporting perspective, so I'm saying yes, open it. Now inside it we can start creating report. Okay, so not template, we'll say new and then report. Okay, the report is, say, movie ratings data. Okay, all right. Now let's say we have here. So you go into the data tab before you design here. There are lots of UI components. Okay, you can do lots of UI. You can do the drag and drop and prepare marvelous report. Okay, you have chart, table, grid, image, data, and whatnot. So there is lots and lots of, you can see that there is cross tab and okay. So I'm a big fan of this particular reporting. In Tibet, my previous company, we had done a lot of work on this. Okay. So let's go to the data. All right. So here, first you have to define the data source. Okay. But before even that, you have to exit the Eclipse. Okay. You have to exit the Eclipse and find out where is the plugin folder. Okay, where is the let's keep it open. Let's keep this folder open. All right. Now the so that was a quick view of how does Eclipse look like, so that we all are motivated. Next is find out all the libraries of Hive. So what I did was I downloaded Hive, okay, from their website. All right. Doesn't look like good. Okay, so it was supposed to be under all of this one single point. So the next big thing is download Hive driver and configure BERT. And then next step is to create reports. Okay, create connection and report. So here is the important aspect. Let me just put it in a text file here, which will look better. So first and foremost is you find out where is your plugin folder. Okay, the plugin folder is generally inside plugins and inside this. Okay, so wherever you have installed Eclipse, it would be inside your Eclipse folder. There'll be plugins and so on. That is on Windows, and on Linux or Mac, it would be somewhere here. Will be inside Eclipse. There'll be a plugins and then rest of the things. So let me show you where did I find it. Show package contents. Inside contents there is Eclipse, and under that there is plugins, and under that I found my folder. Okay, here somewhere. And then that was my plugin folder. This is where I need to put all the data. Now then I went to Hive's website, downloaded all the downloaded the full distribution, and then once I downloaded it looked like this. Okay, after I extracted this it looked like this. Then I went to lib. Okay, bin or lib. Yeah, it was in lib. I think it was here. Okay, now I copied all the jars from here to my plugin folder. Okay, so all the jars, so objective is take all the jars from Hive distribution, put it in the plugins. Next, download Hadoop. I downloaded Hadoop and I found the Hadoop Commons folder inside that. So this what I downloaded, 200 MB. So inside that I found the Hadoop Commons folder of a jar, and that too I copied into plugins. So this is the only difficult step, and that took me a little bit of time. So all you have to do is find out where is this folder. The folder will look like something like this. Inside plugins it will look like Aux, Eclipse, BERT, report, data, ODA, JDBC, and inside that there will be a drivers folder. This number might be different for you. Okay, first find out this folder, then download Hive jars, all of them, and copy all of those jars into this folder, and then uh, download the download the Hadoop version, and from there pick up the Hadoop Commons. But before that, find out what is the version of Hadoop. Right now, this is the version which is installed on the server. Okay, once that is done, you can start creating these reports happily. Okay, so I have already done all of these steps. So if you want to know more about it, I've put one reference point from Hottenworks, which is something which works fine. Okay, so since I've already done it, therefore my Eclipse is able to talk to the Hive server. And where is Hive server installed? It's installed on c.cloudxlab.com. Okay, let's try to see if we can fetch this movie data here. Okay, so we are creating a data source. Select Hive data source. And instead of localhost here, we say c.cloudxlab.com. And what is the database name here? BDA demo. And username is the username which this LMS gives me. Let me refresh it. Okay, let me copy it to. Okay, so that's our database. And before doing that, I think what we could have done is we could have tested it first. It says connection successful. Good. That means our main battle is over. And to reach to this connection successful, it takes some time. All right. So now, what do we want to do? We want to say select star from, what was the table name we had? The table name was in the BDA. What was, all right, data sets. Okay, select Hive queries. Okay, why doesn't it show us our select star from schema? Why doesn't it show us our own thing? Anyway, never mind. So select star from u underscore data. Was that the one or was it something else? What was the name of the table? Name of the table was u underscore data. Good. Select star from u underscore data or select star from v1. Okay, that's our view. So it says that SQL statement does not return this. Oh, okay. So I think you can't add view here. So therefore, let's just try to put a data set. Yeah. All right. So we'll say u underscore data. All right. It doesn't refresh for some reason, but never mind. SQL statement does not return a result. A table not found called u underscore data. Okay, so what we will do is we will refresh. Can I refresh somewhere? Somewhere? Okay. All right. So we can we had to put in here. Yes, we can say select star from u and schema. We could say b bda. All right. I think it's creating a table or something. Alright, so let's just put the name here. It just, the strange thing is it should have shown me the, because here it shows clearly the name of database is called BDA. Oh, I have been doing it in BDA-SG itself. Oh, okay. What happened to the other one I created? Okay, that's correct. Then let's just put it. Okay. So didn't I create another database? All right. So now what we see here is that Cannot get result metadata did not crable not found called u underscore data. That's correct, right? Yeah. Oh, here BDASG. Okay. Now it has brought this data. Now you will see something that we could do a lot of magical things with this here. We could basically take this and represent it beautifully. As in, let's say we want to go here in the palette and want to put aggregation at the bottom. Okay. And we could say we could do all kinds of complex things here. Okay. Let's say we want to take this column and we can put images around it. We could put charts around it. So and we could take a data like select data from here and okay, so you could do very professional reporting here. Okay. Okay, you could say things like this. Now this is done. Now we have just put some data here. I know that it's going to be humongous data, and let me just put one more thing here in the data sets, and I'll just limit it to say 100 records. Okay, so that it doesn't flood our UI. Now we've just created some random graph. We could have created more meaningful one. All right, so it's basically contacting our Hive server, and then if required it will execute the SQL query and then get the data for you. And if required, it might run the MapReduce. Okay. All right. You can see that it has brought the data from the server. Okay. Although I can't see the chart actually. Oh, here is the chart. You can see the beautiful chart. All right. So that's the magic of the BI. All right. So the business analytics, this is what was called the traditional analytics. Now, this Hive has bridged the gap between the traditional analytics and the new one, while on the other hand, the distance between the data scientist or the high-end data analytics or predictive analytics has been bridged by Spark-R. Okay, all right. So did that make sense to you, Mehdi and Anusha? Great, great. So you should try out this BI tools. BI tools itself are in high demand, and uh, and if you know, so at least you should try the bird. Okay, you should try the bird. Should download this bird and try to configure it. It should work out well. All right, great. Thank you, Anusha, and thank you, Mehdi. And I think Saheb has got logged out. All right, great. See you tomorrow. Bye bye. Have a great day.